Stretching the graph of f of x horizontally away from the y-axis is given by f of b times x, provided that b is between 0 and 1. F of x stretches away from the y-axis by the scalar 1 over b. Consider f of x equals the square root of x, and its transformation h of x equals f times 0.5x. Here you see the original graph in red and the new graph in green, stretching away from the y-axis. The graph h of x is the result when f of x stretches away from the y-axis. Shrinking the graph of f of x horizontally towards the y-axis is f of bx, provided that b is greater than 1. F of x shrinks towards the y-axis by the scalar of 1 over b. Consider f of x equals the square root of x, here in red, and its transformation g of x equals f of 2x. The graph g of x is the result when f of x shrinks towards the y-axis. So you have our graph here, and all of a sudden it shrinks this way towards the y-axis. Let f of x equal 5 plus the absolute value of x. Write the rule or formula for the new function after the given transformation. Alright, so we have f of 2x, so that would be 5 plus the absolute value of 2x. Here we have f of 6x, so that's 5 plus the absolute value of 6x. And finally, we have f of 1/3 x, so that would be 5 plus the absolute value of 1/3 x. Now you can also remove this coefficient to the front like this, the 1/3 times the absolute value of x, like that. That also is a correct way to write it. Let f of x equal 8x minus 2x squared. Its graph is displayed to the right. The function g is given by g of x equals f of 0.5x. Carefully sketch on the graph of g of x on the grid to the right. Label at least 3 points. Write a formula for g that does not involve f. I'm going to do this step first because that will help us plot out our points. So g of x equals, so we have 0.5x. So we're going to use this formula here, but everywhere we see x, we're going to put 0.5x instead. So we have 2 times 0.5x squared. So that equals 4x minus, alright, so if we have 1/2 x times 1/2 x, that gives us 1/4 x squared. But then we're going to take this 1/4 x squared and multiply it by 2. So that will give us 1/2 x squared. So now we can use this new equation here to plot our points. At 0, if x equals 0, our output will still be 0, so our point will still be here. And let's try at x equals 2. So when x equals 2, g of 2 equals 4 times 2 minus 1/2 times 2 squared. So that's 8 minus 4 times half is 2, so that equals 6. So now this point is here. Alright, let's try at g of 4. We have 4 times 4 minus 1/2 4 squared. So that's 16 minus 8. So that would be 8. So look, the vertex of this parabola has just moved over away from the y-axis. Let's try when x equals 6. I'll do this work up here. G of 6 equals, so we have 4 times 6 minus 1/2 times 36. So we have this 4 times 6 is 24 minus 36 divided by 2 is 18. So that is 6. So when x equals 6, y also equals 6. So we can draw our parabola because it looks like that. Once again, I'm not a very good freehand drawer. Alright, so we have our answer here. So now our parabola has stretched away from the y-axis and it's much wider than it was before. And our new formula is 4x minus 1/2 x squared. Let f of x equal 0.5 times x plus 4 times x minus 2. Its graph is displayed to the right. The function g is given by g of x equals f of 2x. So we're going to carefully sketch the graph and write a new formula. So let's write our new formula. So anytime we see x in here, we're going to replace it with 2x. So that gives us 0.5 times 2x plus 4 times 2x minus 2. So I'm going to distribute this half here into this expression, and that gives us x plus 2 times 2x minus 2, but let's take 2 out of there. So then we have 2 out front, and then we have x minus 1. So here's our new equation for g of x. Now we are going to find our new zeros. So as you can see, we're going to have a 0 when x equals negative 2, which is half the amount from negative 4. So remember, we're going to take this 2, and then everything's going to move by the scale of 1 over b. So in this case, b is 2. So we have 1 over 2. So negative 4 becomes negative 2. This 0 at 2 becomes 1. As you can see, we can have 1 minus 1 equals 0. So we have our new 0 here. If our vertex was at negative 1, now it's going to be at negative half. So if we plug negative half into here, we will get negative 4.5 at half instead of at 1. And our y-intercept is still going to be at negative 4. So we can draw our parabola like that. And here we go. So as you can see, our vertex was at negative 1 comma negative 4.5, and now it's at negative 0.5 negative 4.5 because the x coordinate decreased by half. So, and there we go, and our new equation. Stretching and shrinking the graph of f of x horizontally towards or away from the y-axis is given by f times bx. If b is between 0 and 1, f of x stretches away from the y-axis by a factor of 1 over b. If b is greater than 1, f of x shrinks towards the y-axis by a factor of 1 over b. Let f of x equal the square root of x, here in red, and g of x is now f of 3x, so it shrinks towards the y-axis like that. If we have h of x equal f of x over 3, so x divided by 3, now it stretches away from the y-axis like this, the orange one.